Okay, I will start the project vulnerabilities because we have a short time. Okay, so initially we selected the project from the GitHub, and it's a Moon e-commerce base, and we selected randomly. We didn't randomly select the project. We selected according to the we needed the vulnerability. So we didn't go through with the high profile companies. We just go with the students' profiles and check get one project, and we downloaded it. And we second things, so we downloaded it, and we also uploaded the modified project after we remove the vulnerabilities also we uploaded over there. And the next thing is the application selection. So application selection reason is I already noted above. And second thing is the vulnerability assessment. So vulnerability assessment for the black box testing, we use the website. So in here, how we show that how we executed the black box scanner to find the coding vulnerabilities apart from the coding. And another things we run because we also need to find the code, right? So in the code, so we used the Sona Cube. So I will show the Sona Cube, and this is how we uh, use the Sona Cube to run those ones. And this is our Sona Cube file. And in here, this is the SSD box. And here we found that there's so many of security vulnerabilities over there. And everyone, we teamly fixed every vulnerabilities over there. So that's the things, and we find a list of identified vulnerabilities. For example, that was attack against pseudo random number generators, having permission cross origin resources, make sure not enabling their content security policy CSP, and the cloud metadata are also potentially exposed over there. And the server leaks information of the X powered by, and the mitigating the rejects backtracking vulnerabilities also over there. And the last one is the sensitive file was found in the black box testing. And here I will start from the my part. I will explain. Each of everyone we divide it into the one white box code base vulnerability, and another thing is the black box testing. So initially, this is my initial a vulnerability, which is the denial of service attack. For this one, we identify the vulnerability related to its content length. I will show. Yeah, we found it in the Sona Cube as we already told. It's a related to the content law, so it lacked the mechanism to reject the excessive content length, make it susceptible to the DOS attack. So we to fix this implemented, we implemented the file size like this to avoid from the mitigating the risk of the DOS attacks. So this is the first one I used over there, and the second thing I will show over there. Okay, I will show over there in the black box testing. The fifth one is mine. Okay, what's the fixed one? So this is the cloud meta data is okay. Give me a second. Yeah, cloud metadata potentially detected over there. Okay, so I will move into the cloud metadata potentially exposed. So these vulnerabilities is posed a risk of exposing sensitive cloud metadata. We fix it by reviewing and updating the Nginx configuration in the for my OAS. So we found this in the black box testing as here it is already over there. The cloud metadata is a high risk security. Then we fixed it by add the code over there to uh, fix it for in the laptop to the access controls were implemented to restrict the access of my IP address, which is showing over there. And so we emphasize not trusting the user data in the ng configuration. And the final part is the and others will explain their part. Okay, I will finish the authentication also. So we did the open we did we did the OpenID part also. So this is the zero auth. So we did the implementation part also. I will explain it in the code section. So this is how we implement it in the code, and we get the uh, API, Google API ID from the Google console, and we attached it into the NV file so that we can easily created and used on the shine in. So I will show one random. So first of all, I will shine out from this. Okay, start with the login with Google, and I will click randomly. This is my profile. So it's I will click one, and let's see. Okay, this is how it created. Now it's a Sudanand. And in the dashboard, you can check that Sudan's photography, get it from those open ID and everything. So that's it. And now the next person will come and start his. I will off my screen.
Yeah, good morning. My name is Saravanan. My ID number is IT 20215224. So in this project, my part is the one of the white box testing and one of the black box testing. So first, this one is a SonarCube white box testing. So my part is the using pseudo random number generator. So this is a bug. So this is our SonarCube screenshot. So in here, using random number generators without adequate security measures in security sensitive. Such vulnerabilities can lead to predicted outcomes and pose security issues. So in here, we use the math random method. So that's the uh, bug in this project. So I fixed this. So in here, this is our fixed code. So we use crypto. So to address this security concern, we implement a fix that to utilize a cryptology. So we use cryptology and implement the code, then it will fix. So that's my first bug in here. So in this report, I explained everything. And my next bug is black box testing. So I will explain that. I think fix one. Yeah, this is my black box testing is so Swana has already show the white box and black box testing report in the Sona Cube and AutoGCT. And this is the black box server leaks information via powered by HTTP response SCADA field. So this is my explanation. So the server leaks information via powered by HTTP response SCADA is security vulnerability related to information disclosure. So this is mainly focused on the information disclosure bug. So in this bug, I will fix also. And in here in my code base, I add the app.disable method. So this is automatically preventing the information disclosure in server information. So these are my two bugs in this project. So thank you.
Hi. I'll discuss two critical aspects of our secure software development assignment. First, mitigating cross-origin resource sharing, vulnerabilities, and preventing denial of service attacks through regex backtracking mitigation. First, we uh, show about the first one, which is the mitigation cause vulnerabilities, which is the application we initially had an permissive cause policy that allowed cross-origin requests from any source. This exposed our application to security risks, potentially compromising data. To address this vulnerability, we took several steps. First, we defined allowed origins and specified which HTTP methods our application should accept. We restricted requests to the trusted domain localhost 8080 and allowed common HTTP methods like get, post, put and patch and delete. Additionally, we avoided using wildcard origins to prevent excessive permissiveness and set the credential of aligning with our specific use case and security requirements. These adjustments significantly improved our application security posture, aligning it with best practices for our app. And the second one, which is the seventh one, um, yeah, uh, this one, yeah. This is the rejects backtracking leading to denial of service, um, which describes regular expression engines use backtracking, which can lead to catastrophic backtracking situation. In the worst case, the complexity of regular expression can be exponential in the size of the input, causing a denial of service attack. Superlinear rejects complexity can lead to same the impact of the large input. So we fix that issue by To prevent such vulnerabilities, we adopted several strategies. We replaced capturing groups with non-capturing groups to prevent excessive backtracking. So these two are my contribution in this part. Thank you.
So good morning, all of you. My name is Sausan. My IT number is IT 283 So in this project, I found two bugs. So first one is I found in white box testing, and second one is black box testing. So first, this bug is found in white box testing. So this is a make sure not enabling content security policy fetch directive is safe here. So in this case, they used a helmet package in Node.js. So in this case, they don't allow the content security policy. So first I enable the content security policy, and then I define the CSP directives. So in CSP directives, I added the allow only resources from the same origin self and from the trusted domain trustedscript.com. So after that, after put it in helmet package, then I test in white box that bug is solved. So this is my first bug. My second bug is okay. This is my second bug. In this bug, I found it in black box testing. So in black box testing, I found the sensitive file. So that file name is dstore. The so a sensitive file was identified accessible or available. This may leak administrative configuration or credential information, which can be leveraged by malicious attacks. So then I fix this bug to when sorry, we have reviewed whether the component is needed to our production environment. So they does not use this file in any file. So I remove this .dsto file. So after that, after remove this file, I checked in black box testing that bug is cleared. So both are my vulnerabilities in this project and fix it. Thank you.